Welcome to Chapter 2, the Internet of Things and how it is changing how we live. And we'll cover a little bit about the information system security and its effect on people and businesses. All right, so the Internet of Things is termed and coined, I guess, in the 1980s to the present, right? And it's definitely had a major impact on the way we live and conduct business. And then it's also, definitely transforming our businesses into more e-commerce models. And then we have our IP mobility, or the ability for our mobile devices that enable all kinds of solutions that weren't possible. But with our smartphones and tablets and other wearable devices, as well as our smart fridges and other devices, it's just incredible what we have available today. But then we have some challenges that are created by this Internet of Things, or IoT. And the Internet of Things has changed and is changing our lives, right? And some examples are, our social media, such as Facebook, Twitter, etc. And then other tools such as voice over IP and video conferencing. Right? That's definitely become really big, especially this year. And then there are many drivers for why Internet of Things is growing. We have the need for faster and smaller computing and more data. And our ability to use IP-based networks has exponentially increased our growth of Internet of Things. And then our connectivity is growing, enabling more and more devices to be connected, and more bandwidth available. Add in our ability to perform better and better data analytics, and with increases in our ability to provide cloud services. And these all factor into why the Internet of Things is growing and impacting our lives and changing how we do things. While I would agree with the order of evolution on this slide, as a timeline, I'm not exactly sure where the book was going with regards to the evolution of the Internet of Things, but maybe I guess the evolution of the Internet itself, which does impact the evolution of Internet of Things. But right, the ISPs came first. RFIDs came into place. Allowing for quick inventory or communication between devices. You have application service providers that provide our first foray into cloud services, and then now we got software as a service, which is complete cloudification of applications. And then we've had the transition to our transmission control protocol, Internet Protocol, or TCP/IP, right, world, and has changed the way we live. People's, families, business, educators, governments, businesses, everybody all communicate differently than they did before TCP/IP and before the Internet of Things. Nearly everyone has easy access to the internet now, and that's just increasing more and more. There's no doubt that the internet has changed how the average person conducts their daily life, right? Personally, socially, professionally, and we can use the internet to do many things, conduct business, social media, news, weather, are just some, and now health, banking, everything can almost be done online now. But you have two different technologies that you can utilize, right? So you have real time, which occurs instantaneously. Think like the stock market. They need real time, responses. Whereas store and forward, there's an acceptable delay in the communications that can occur, like email. is something that is a store and forward. It's not so real time. And then we've, like I said, we're getting into health monitoring and updates, home security, smart homes. You can have shared family calendars, near real-time tracking and monitoring via GPS. So you can know when your pizza is going to be delivered. Online banking, bill pay, financial transactions, online e-commerce purchases, you name it. This and many more aspects change just the consumer's life. And then on the business, right, the way we do retail, virtual work environments, working from home, remote sensors that can do checks and report back and data, traffic monitoring applications. Business to computer service delivery model has changed. You have a concept of anything as a service. You think about it, you could probably provide it as an online service in some way, shape, or form. Whether a transaction is business to consumer, B2C, or business to business, B2B, more and more often it is going to occur online. And then with that, if it's dealing with credit cards, then you've got the PCI, the Payment Card Industry Data Security Standard that you would have to comply with. Some of the top challenges for businesses today are: how do you grow through the internet? How do you change from a brick and mortar to an online business? How do I secure and scale my online business? Building an online customer service strategy. How do I do that? What is needed? And then how do I perform effective internet marketing? These are all new challenges that didn't exist before, but now they're almost required for almost any business, and definitely required for any online business. And here are 4 key or core strategies, concepts that online businesses need to deal with today, right? Their e-commerce solution, their marketing strategy, the customer service delivery strategy, and then the payment and credit card transaction processing. Online businesses must have an internet and internet of things marketing strategy, or they should, but having an internet presence also exposes organizations to online risks, threats, and vulnerabilities. But businesses need to find ways to remain competitive. The brick and mortar model is clearly out of date for most businesses. It needs to change. And then customers definitely require continuous access to information, products, and services. Once again, all of this still, by providing it online, it exposes organizations to online risks, threats, and vulnerabilities. Today, consumers are now extremely mobile, right? We have powerful communication devices, and phones have extended our mobility and our need to be able to do things while out and about. No longer is it just at home or at work. We can be, in our car, unfortunately, and expecting services. But of course, maybe you're using maps or something like that to get somewhere. But at the coffee shop or at the anywhere out at a friend's house or whatever, you can get on and do mobile transactions now. And then you got tablets, smartphones, netbooks, and all kinds of more portable devices, wearables, etc., that just increase our mobility. Many organizations have the ability for an employee to bring their own device, BYOD, but this presents many IT challenges such as networking, usability, and security challenges. Mobile applications, they're better than web applications on when you're on a mobile device, because limited web browsers can't run some of the features that you find in traditional applications. And then for mobile devices, right? So applications that aren't really mobile, you have bad interface designs that cause application failures on mobile devices. And then many users from multiple domains find uses for mobile applications, right? More and more people prefer mobile applications. And then medical applications are finding that they're a pretty good fit on our mobile devices. 4G provided our first true IP networks and have added features such as staying connected without interruption while moving between land and lands, or just staying connected in general as long as you're in the network coverage area. Mobile IP provides connection transparency for several entities working together to ensure the mobile device can move from one network to another without dropping connections. All right, and some of these actors, or you will, that are what you find in a typical mobile network. The mobile node, or MN, is the mobile device that moves from one network to another. So your phone, right? The mobile node has a fixed IP address regardless of the current network. The home agent, HA, it's a router with additional capabilities over standard routers, and the home agent keeps track of the mobile node that it manages. And when the mobile node leaves the local network, the HA, let me go ahead and and then forwards the packet. And the forward agent is another router with additional capabilities connected to another network, but not the home network. And the foreign agent assigns the mobile node a local address. And then when the mobile node connects to another network that supports mobile IP, it announces itself to the foreign agent. And then the care of address, or COA, the local address for the mobile node when it connects to another network, and the foreign agent assigns the care of address to the mobile node and sends it to the home agent, right? And then the corresponding node, or CN, this is a node that wants to communicate with the mobile node. So that could be a server or another device. And this is just depicted mobily, right? So you have the mobile node at the bottom, which is your cell phone, right? The foreign agent is, a router, that you're connected to in that area, wherever you're in that area. The care of address is the address that you're assigned from the foreign agent, right? And then you have the home agent, which is your cell phone providers or your network providers router, the home agent. And then you have the internet, and then whatever your resource you're trying to access, right, the corresponding node, right? And I'm just going to skip this slide because it just basically goes back over what the last slide was showing again, in what order. But you can definitely look over it if you want and toggle back and forth between them. New challenges created by the Internet of Things, right? Security. How do we keep the bad guys out if you enable Internet of Things for your personal and professional life and you have all these accesses and software and nodes and everything open, right? And then privacy. How do you protect your family's identity, your identity? You keep your data private and keep it, from being stolen or accessed. And how do you prevent identity theft, right? These are major concerns that are opened up with IoT. Interoperability and standards, right? So how well do the Internet of Things, the manufacturers and the application server providers and developers, how do they ensure the devices communicate securely and together, right? How do they work together? Legal and regulatory compliance. What role do the international, federal, and state levels contribute towards legal, tax, and regulatory requirements regarding the Internet of Things, related business transactions and payments, um, you know, as well as the different goods and services, right? Some are regulated, so it's like insurance or something like that. You know, it's heavily regulated in itself, but now with the Internet of Things, there's even more options that may need to get regulated. Then e-commerce and economic development issues, right? What are the economic rules of engagement for conducting business on the World Wide Web, and how is Internet of Things connectivity and information sharing to be deployed globally? I mean, these are some big challenges. And then we've got security challenges of the devices themselves, right? How do you deploy in large quantities? Ambiguousness, you know, you know, and can have wide reach into the user or household populations, right? How do you keep you anonymized, right? Your privacy, right? Um, you know, the device is not maintained or updated, allows for vulnerabilities. Upgrades can be difficult to distribute and deploy. Yeah. And then the owner visibility of how the device connects to the internet, right? It connects, you just trust it, right? You don't know, you rely on it to be safe and secure. The device itself, right? It's so easy, to be stolen and lost, and what happens then when your whole life is on your phone, right? And it gets stolen. How do you get it back? How do you prevent somebody from accessing it? And then you capture readings and measurements are in the open sometimes, right? How is it secured? But definitely one of the biggest challenges is privacy. How do we address privacy? Um, you know, all the data, the metadata, and analytics that can be done. I mean, what are our rights? What are the user's rights? What are your customers' rights? And then, is our consent, right, enough? All these statements that you sign or agree to, right, that nobody reads. Is that a good? Is that really providing consent? And then, yeah, I mean, it's just a mess when you look at it. How are we going to handle this, and how should we handle this? Interoperability and standards. Once again, right? We do have the Internet Engineering Task Force, IETF, right? And they try to ensure the interoperability, and then there are standards that Internet of Things providers and manufacturers should adhere to, so that devices work together and solutions are easier to develop. And that makes it more financially accessible and easier, right? Because if you don't have interoperability, you can have significant financial impacts trying to get things to work together if you have to reinvent the wheel, or try to get two devices to communicate using two different formats, right? And so the goal is just to bring the cost of IoT devices and applications down so that they're more affordable. Some manufacturers want to design and deploy proprietary devices, though, and solutions. They don't want it to work with others, right? But it's at a cost sometimes, and it's a higher end version. But it does have cost factors, both operational, technical, and even security wise. There's time to market risk by doing your own proprietary solution. And then technology outdated, right? Because of how fast we're moving. If the business chooses to go that route, they could be shut out of the marketplace really fast, by an innovative mover that develops something, some new feature that isn't very easy to build into their proprietary solution, right? And then you have legal and regulatory issues, right? Proper handling and protection of data, privacy data subject to privacy laws of the state you live in or country you live in, and industry, right, that you're working in. And then IoT vendors or solution providers are required to adhere to security control requirements and data protection laws. Yeah. Some questions to ask: who's collecting the data? Who's collecting behavior patterns? Are they selling this data? Do they have the right to sell it? Is there liability associated with the data? Right? These are just some questions you should be asking when you're using a service. IoT, Internet of Things technology, has a significant impact on developing economies. Right? Infrastructure resources, right? They're foundational to the development of IoT. Having a communication infrastructure and broadband internet network are needed within that country. This is the foundation for Internet of Things device connectivity and communications in a global marketplace. So you have to have that infrastructure resources. Foundational investments, countries seeking to invest in critical infrastructures may be able to leapfrog past other countries that are struggling with regulatory and legal issues in regard to accelerating deployments, right? So they may not have to go through the pain that some countries have because they're going later, and getting a big push of investment, so they can leapfrog past other countries, right? Technical and industry development. New skills are definitely needed to bring in new technologies and economic solutions to bear using the internet and the Internet of Things. Especially if you're looking at to be an economic driver, so you're going to have new skill sets, new types of jobs. As IoT technology and industry interoperability and standards mature, so will the Internet of Things device deployments and users and business adoptions. But it's a maturing industry, but for a lot of countries, they lack the skills right now, but it's changing. And then finally, policy and regulation definitions. So countries and emerging economies are positioned to create and implement policies and regulations to help ensure that security and privacy become part of the deployment and development of IoT. And that ends our Chapter 2, Internet of Things.